Hello and welcome to another video. In this video we're going to be working on sort colors, and in this one you have an array nums with 3 types of numbers, 0, 1s, and 2s, and they're just some color. And you want to sort it in place, so 0s come before 1s, come before 2s, and you want to not use a sort function, and you want to do it in linear time. So how do you do that? And you want to do it in constant space. So there's a really easy way that I didn't see it in the solution, but it's constant space, but it's really easy. So I'll talk about that briefly, and then I'll talk about a more advanced one that you're probably not expected to know, and it's a little bit tricky to come up with, but it kind of makes sense. So the really easy way is you can just count up each number. So you can say like 0s, 1s, and so on, right? 1s, let's say you have 5, 0s, whatever, 5, and 2s, 5. And then you can just go through, once you get these 3 counts, you just go through your array, you just put in 5 0s, 5 1s, 2 2, whatever it is. So this is like super easy. That would be basically an easy problem, and that would give you constant space, linear time, all that stuff. So this is basically like a counting sort because you know exactly what values you have. There's not too many, so perfect scenario for that kind of problem. So the trickier way, let's look at it. So basically you know that 2s need to be at the back, 0s need to be at the start, and 1s need to be in the middle. So essentially we can just have pointers for all these things. So we can say like, okay, we'll have a pointer for where 2s need to go, we'll have a pointer for where 0s need to go, and then we'll have a pointer for where we're at. And if we get a 2, we'll put it where the 2 needs to go and take the value that's currently there and put it in the value we're at. If it needs to be the start, we'll put it at the start, and we'll just update these 2 pointers. So we have a third pointer, let's make a different color. And this will be where we're currently at. So here, in the beginning, we're at a 2. So we know the 2 needs to go at the end. So we're going to say, let's put the 2 at the end, and whatever value is at the 2, let's put it where we're at now, and then we'll deal with that value later. So we'll put the 2 over here, and we'll put the 0 here. Now we have to check again, because our value got changed. Okay, we're at a 0. So the 0 just needs to go right where the 0 needs to go, and then we can move on. So the 0 will go here, and then we'll move on. Now we are at a 0, so we'll put it where the 0 needs to go and then move on again. Now we're at a 2. Oh, by the way, so when we put a 2 here, this will shrink. So now we're at a 2, so the 2 needs to go where the 2s need to go at the end. So we're going to put a 2 there, and we'll put a 0 here. We'll just swap. Okay, and now the next 2 should go here. Now we have a 0, so we just put a 0 right where we're at, and then we keep going. Now we have a 1. So we know all the 1s need to go between these 2 things. So actually, if we're at a 1, we don't need to do anything. We can just keep going. So we can just keep going here. We're at a 1, so we can keep going. Now we're at a 0, so we know the 0 needs to go here. So we're going to swap. And we're going to move this over here now. Now we're at a 1, so we don't need to do anything. Then we're at a 2, so the 2 will go here, and the 1 will go there. And then basically, once your current pointer passes like the right pointer, you're done. And notice how this is sorted now. So the basic idea is just, if you're at a 0, put it where the 0s need to go. If you're at a 2, put it where the 2 needs to go. If you're at a 1, do nothing. And just keep moving this up every time you do what you did. And every time you put in a 0, move the 0 up. And every time you put in a 2, move the 2 back. So it's kind of similar as like put all of some number in the back of an array or something, kind of like that, with 1 pointer, but this is with 2. So hopefully that makes sense. I think it's like reasonably, like if you were to ask like, come up with a solution with pointers to do this, I don't think it's like too hard. Like that's basically what I did. I was like, okay, I know this one, this is super easy, but there's also some other solution with pointers that's a 1 pass. This is basically a 1 pass. Let's just like try stuff out and see what happens. And it's kind of obvious, like you know where like you need to have a pointer for 2s, you need a pointer for 0s, and then what do you do for 1s, and you can kind of just like figure it out. But this isn't super intuitive to come up with, so it's kind of like, if I was asked you to make a solution like this, can you do it? And I think that would be like an okay interview problem, like given an array, use some pointers to move stuff around and make sure it's a 1 pass, and don't have a solution like this because it's super easy, and that wouldn't be like a medium problem. So let's code up this guy. So we'll have 2 or 3 pointers. So we'll have int left, int right, and current, or I. So then we'll say while I is, and you can kind of just play around with like this solution and just try it. And then once you get edge case, like think of edge cases, try some stuff out, make sure that it works. So this is going to be I is less than or equal to right, I believe. And then once I passes right, then we're done. Because you actually do have to check the right value, because the right value can be like a 0 and then you have to swap it and things like that. So basically we have a couple cases, right? So first we'll just get the number. So if our number is 0, then we need to swap it with whatever's at the left pointer. Yeah. So if our number is 0, current number is 0, we need to swap it with whatever's at the left pointer. And then it turns out you can actually just move up the current right away. So if this is 0, we swap it with a left pointer. And then, yeah, so let's do that. So we'll say, let's see, nums left equals, actually we want the other way. So we want nums I equals, this should be this, nums left, and nums left is going to be a 0, and we move them both up. So this is just, we can increment here and here. Okay. Yeah. Now another case, we have 3 cases, right? If it's 0, 1, or 2. Yeah, so let's do the next case. So if it's 2, then you don't increment your current number because you have to swap. You have to swap your numbers, but then you might get another 2 or so on and so on. So if this is a 2, then nums I needs to be nums right. Nums right needs to be 2. And this actually needs to be decremented. So like this. In fact, I think it's even easier. Instead of incrementing I, let's just not increment I at all, and this will make the code easier to read. So we'll just say if our number is 0, just do a swap, but don't increment I. If our number is a 2, do a swap, but don't increment I. Only increment the thing you're flipping with. Otherwise, let's actually do our swap. So this is going to be if the number is a 1. So if the number is a 1, then we don't do anything. We just increment I. So, and I think there is a case here because we don't increment I can be behind our left pointer. So for example, let's just say like we have this. So I can actually be behind the left pointer because if you do this, the left pointer will actually be over here, and it doesn't make sense for I to be behind the left pointer. All right, so like here, 0 would get placed here, and then this would move up because we're not incrementing I, and then this is still 0. So if I is behind the left pointer, then we can just move it up. So that'll be another case. So we can say, we can do that for the first. So if I is less than left, we know that everything before left is 0, so we don't care about those values. So we can just move it up and just continue here. So this is like the easier solution. The other one is a little bit more concise, but this one makes a lot more sense what's going on. And then, yeah, I think that's it. Okay. So this is like the trickier solution. Hopefully this makes sense. Like you basically either do a swap and don't move I, or if I is 1, you do move I. And if I is behind your current left pointer, like it is here, then you just move I up because everything behind the left pointer is all 0s. So you don't need to do anything. You just move it up. So there we go. Yeah, and this is going to be a 1 pass and 1 space. So hopefully that was helpful. If it was helpful, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.